All right, good afternoon, everybody. Welcome back to another live stream. So today we are taking yet another little bit of a deviation from our Summer of Rag series, but this deviation is in support of a future stream here. So what we're going to be talking about today is how to perform AWS deployments using OpenTofu, Scalr, and GitHub. Now, admittedly, today's going to be a little bit more of an intermediate topic. Like, I do try to keep these streams more beginner friendly, and I'm going to try to keep this one as beginner friendly as possible too. It's just that there's a lot going on with this one, so there will be times when I will purposefully kind of gloss over a specific piece, because if I covered every single piece, we'd just be here all day. But I will try to make note of specific, like, other learning resources that you can use to upscale in certain pieces. So let's talk about the motivation behind this. So I'm assuming you already know what AWS is. So AWS is a cloud platform where you can deploy whatever you need to deploy out there. We've used it for machine learning purposes in the past on these streams, and I'm sure that many of you have used it for a work-related context. Now, so the way in which most people are familiar with deploying cloud resources through AWS, and it's not even particularly with AWS, Azure, Microsoft, or Google Cloud Platform. All these cloud platforms have some sort of user interface in the form of like an AWS console, or what is the Azure call? Maybe it is just called the Azure console these days. But anyway, so it's this user interface that you can go to via web browser. And like, let's say that I wanted to create a Lambda function, AWS Lambda function. Then simply all I got to do is I got to go to the Lambda service, click through a couple things, and I'm on my way. So there is this, I mean, there's nothing particularly wrong with that. But if you think about trying to do that at scale or in a replicable way, then the way I just described is not really an efficient way of doing things. So what we should do, like, so imagine if you had to create 100 different Lambda functions, and like, let's say they all had to do something very similar, but it was just like one little nuance change that in the form of code, you could do it a lot easier. Something like a for loop in a typical programming language, you might be able to like propagate a number of these things. Trying to do that in console is not really possible. I mean, technically it is, but imagine trying to go through and create 100 Lambda functions all at once. Or, like I said, also, like, the other thing may be that let's say like you are experiencing some sort of scenario where maybe one of the AWS regions went down and you have to redeploy your code to another region very quickly. If you have a full code base and a full tech stack and everything, trying to do that all manually via something like the console is just not really possible. So what we can use to this end, well, so like, let me be clear, like a couple of these cloud platforms have provided their own version of like how to manage this with code. So they call this infrastructure as code. And so like AWS, they specifically offer a service called CloudFormation. Now, more recent, so that is, there's nothing wrong with CloudFormation or whatever other services that Azure or GCPS offer. The problem with those is that they offer like the syntax and the flavoring of like infrastructure code that they use is not consistent. Meaning that like if you want to use CloudFormation versus one of these other guys, then you have to learn a whole new syntax, and nobody wants to do that. So that's where something called Terraform came in. So Terraform is this infrastructure as code platform that allows you to write code in a seemingly like similar syntax. So that way, like if I'm working on AWS one day and I'm working on Azure another day, then yeah, they're going to be different services, and I'm going to have to use different code at the end of the day. But like, try and understand how that infrastructure as code piece of work. Oh my gosh, I can't even speak right now. I hope trying to understand that is, or how Terraform works is easier, just because you already had experience with Terraform in the past. Like you can actually, the way that Terraform actually works then is like when you run, you write your Terraform code in some sort of IDE or whatever on your computer, and then you would deploy that out to, like, you would use the Terraform syntax or whatever to deploy the code out to AWS or whatever. And then on the back end, you have what is called a TF state file that is saved, a Terraform state file, TF there. And so what this state file basically has is it has all the information about the resources that you deployed. So if you deployed out 100 different Lambda functions and you got all this specification about them. Then the way that Terraform remembers that you deployed all those is with this TF state file. And so you might be then thinking, okay, well, if I work in a giant company and I got 100 different people like me that are deploying all these different things, I want those Terraform state files, those TF state files, to be in one location. Additionally, I also want something else, and that is this ability to be able to control what people can and can't deploy. So, for example, like maybe like you don't want everybody creating their own VPC. VPCs can be very expensive, and you probably want them to be managed by your information security team or whatnot. You would probably want a rule that said, okay, even if you can write the code for in Terraform to create a VPC, and when you deploy it, I don't want you to do that. I want something that blocks you from being able to do that. So like at an administrator level, I'm saying nobody below the administrator level can deploy VPCs. And so let me recap those two problems there. And I know I'm getting a little bit talky heady thing here, and we will jump into code and showing more screen stuff. But I want to lay the framework here. So the two things there again is we want to centralize all of our TF state files, and we want to be able to way to set policies for people to be able to do or not do certain things. So what Terraform themselves came up with. So Terraform is owned by or originally created by a company called HashiCorp, and they have a couple other different products as well, Vault and Console and whatever. So one of the product offerings that they started to offer to solve the problem that I just talked about is something called Terraform Cloud or Terraform Enterprise. So basically Terraform Cloud and Terraform Enterprise, they're more or less the same thing. It's just the one is at an enterprise level and the other one's not. So like Terraform Enterprise, what it can do is it will do that centralization of the TF state files for you. So if I'm like an individual developer and I start doing all my work, all my TF state files reside up in Terraform Enterprise. So if I ever leave the company or whatever, if anything, then the company's not screwed over because all your stuff is in the TF state files, in the Terraform Enterprise itself. And then you have what are called Sentinel policies. And so these Sentinel policies, this is covering the second problem, and that is where you can set these specific rules, and they can be like advisory rules or like full stop rules. So like advisory rules would be like, hey, I noticed you didn't have certain tags on it, but we're going to let you go forward anyway. Whereas a hard stop rule would be like what I talked about with the VPC, like where it says if you have a VPC, you are going to get stopped and you are not going to be able to create that resource on AWS. So the reason I bring that up here is about this time last year. So Terraform itself is a bit of an open source product. And I say a bit of an open source product and that is because like I don't really understand this full thing. So I got to be really careful about how I address this. Like, and so I'm going to try to address this in the way that I understand it. And just to be clear, I'm not trying to make any personal judgments about any products here because I feel like I'm not trying to misrepresent anything here. So about this time last year, HashiCorp was not happy that so we just talked about Terraform Enterprise. There are other competitors out there that are creating alternatives to Terraform Enterprise, and from what I understand, they're at a significantly cheaper cost. And so in order to kind of curb around that, what HashiCorp did is they decided to change the licensing from a less restrictive open source license on Terraform to like I think what is called like a business source license, a BSL or something like that, and basically says like, okay, anybody going forward that wants to use one of these alternative products to something like Terraform Enterprise, they're going to have to pay an extra premium on top of that to continue using Terraform. And so, as you can imagine, people didn't take too kindly to that. Now, the thing about this change, though, is that it could not be retrofitted, meaning that like it could only be applied to Terraform going forward. Is that going forward? Okay. I always got to remember it's backwards for me because it's this way. All right. Anyway, so going forward, but anything at this point back in time, then that was all still like purely open source. So what happened then? So that the Linux Foundation, who has all these different open source projects, said, okay, well, if you're going to be that way, HashiCorp, then we are going to create our own fork of Terraform called OpenTofu. And so that's why I'm covering open. And so so we're covering Scalr today because Scalr is one of those main competitors to Terraform Enterprise, like I was talking about. And we're covering OpenTofu today because going forward, Scalr is not really going to be able to use Terraform unless the customer wants to pay that extra fee. And I will tell you, like, as at least as of today, OpenTofu and Terraform are pretty much the exact same. Like, there may come to a point in the future when these two frameworks deviate enough, but it's been such, like, I think it's been right about a year now since that happened, and like, in my experience, basically nothing has changed. Like, I think there are extremely minor changes between the two, but like nothing that I could really see that was a concern. And the other thing I should note is, like, so the actual code, so like whenever we deploy stuff out to AWS versus versus Google Cloud Platform versus Azure, we call those in the Terraform world, we call those providers. That provider code is under an Apache 2.0 license that cannot be touched, meaning that, like, the OpenTofu code, the OpenTofu framework for deploying code can still make use of the AWS provider Terraforms, no problem. And so if you came here today and you have experience with Terraform and you're wondering, like, what the difference for OpenTofu is, it's basically nothing. And you will see that here. All right, so I set the table here. Like, I know that was a lot of talking there, but let's actually jump into some things. So, let me give two more things. If you have questions throughout, I am taking questions on both LinkedIn and YouTube. The one thing I've noticed is it seems that, like, the LinkedIn questions are slow. I don't know why. Maybe that's just a bad perception. So if you want a more immediate answer, I would suggest asking on YouTube, but I don't care which platform you ask. Just wanted to note that. And then the other thing is like, so 100%, like, I always do pre-prep for these streams anymore. I did 100% of what we are going to be doing today on my iPad over here. And so you'll start to see some of the motivation for why I chose to do some of the things. Like, you could do everything on a Mac or a Windows machine here, but I'm just one of those weirdos that like coding on an iPad. And so everything that we're going to be doing today can technically be done on an iPad. All right, so let's just go ahead and jump into things. So, all right, so you can see my screen here. We're going to keep things extremely simple today by just on AWS creating a single IAM role. Nothing fancy at all. And so actually the first thing that I like to do whenever I'm creating something for the very first time is I actually do like to create it in, like, one instance of whatever I'm trying to create in the console first. So let's go ahead and go into the console. So this is my personal AWS account. Let's go ahead and jump into the IAM role. We're going to create a single role with a single policy, and it's going to be extremely simple. So I'm just going to go into roles here. I'm going to create a new role. And so if you're not familiar with how the roles on AWS works, is like you can set a trusted entity type that can assume these things. So I'm going to pretend as if I'm creating an IAM role that any Lambda function can assume. And again, this is a little bit more of an immediate stream, so I am making some assumptions that you do know some of these basic AWS services, but I'm going to try to keep it basic. I'm going to try to keep it to like IAM and Lambda, and that's about it. I'm not going to go into Neptune or Athena, or I'm not going to try to trick you all like that. So we're just going to keep it super simple. We're just going to say a Lambda function because Lambda functions are extremely popular on AWS, which is why we're picking one of these. So the next thing that we can do is that we need to create a policy or an attachment policy. And it looks like you do actually have to create the policy before you can attach it in the console. Okay, so I'm going to do that first. I'm actually going to just abandon this. Let's go and create the policy first. So creating the policy. So the only thing that I wanted to do is I wanted to have just like, I wanted to be able to just list out buckets. Yeah, just list out buckets. How about that? Does nothing else, can just list out buckets. We're just keeping it extremely, extremely simple. So let's go ahead and go to next. And oops, what did I forget here? I'm just going to select all. So like all buckets. I don't care what it can do. Can't do anything but list the buckets, and it can list all of the buckets. All right, so next, I'm going to call this policy IAM S3 bucket list policy as such. And you can see here, like, it's extremely limited in what it can do. Create the policy. Boom. Policy created. Now I'm going to go back to my role here. I'm going to create the role. And like I said, we're going to have a Lambda function to be able to assume it. And then I don't even remember what I called. Okay, here it is. IAM S3 bucket list policy. We're just going to attach this only. And you could see here, so this is what the trust policy and stuff looks like here. and this can kind of be informative a little bit, like and you'll see how this actually kind of correlates to the actual OpenTofu code itself. And by the way, when I say OpenTofu, like I said, if you know Terraform, you know OpenTofu. Like the syntax is going to look almost identical. In fact, some of you are going to be like, where does it even say OpenTofu? Because we're actually going to type the word Terraform at one point, and we don't type the word OpenTofu at all. So, all right. So we're going to create the role here. Oh, I got to create a name for the role. S3 bucket lister role. All right. Just going to call that. Nothing fancy. All right. So that is creating the role. So imagine trying to do that a couple hundred times. So not great in or creating all these other different resources. So we created it. So I'm going to go ahead and already just delete it. So I don't even remember I got to remember these things in the future. So I'm just going to delete this out now. S3 bucket lister role. Okay, delete. Okay, and then policies, we are going to go to the S3 lister. Okay, delete. I am S3 bucket policy. Bucket list policy. Bucket list policy. There we go. All right. So the first thing that we're going to go ahead and do is, well, actually, let's take a step back and let's walk through the flow of how we're going to do this. So over here is my source code repository. This is GitHub. You may use GitLab. There may be other ways in which you want to do things. And there are multiple ways to kick off an OpenTofu build. So just let me take another step back just to really hammer how things are going to work here. We are going to use Scalr as our compute platform to deploy our OpenTofu code to AWS, and Scalr is going to manage our TF state file. Now, I'm not going to talk about the Sentinel policy equivalent because I frankly don't know how to do that on Scalr. And I just wanted to call that out to make you know that is aware. Or I'm sorry, that you are aware that is a feature. But anyway, so there are multiple ways to trigger a Scalr run. One of them is more manually. One of them, and so if you work with me, we actually use the more manual run, and that is where we actually use the command line to be able to do this. But another way to do it is actually just having anytime you actually push up your code to a specific branch, it will automatically fire off. So what I'm going to do here is we're working out of our LLM RAG guide here. So let's say that I have my OpenTofu code here, and I've been pushing it up to this OpenSearch server list thing here. So we're not going to be doing anything with this specific code here today. Just trying to give you an idea of what we're going to be doing here. So anytime I actually make any changes to this code here, then Scalr is going to run and then deploy this code out to AWS. All right, so how do we set this up then? All right, so what you're going to need to do is you're going to need to create a Scalr account. So I'm going to assume that you've already done that. I'm not that's pretty straightforward. And then you're going to need to do a couple of different things. So the first thing that you're going to need to do is you're going to need to connect your source code provider to your to Scalr. So if you I actually signed up with my GitHub account, and because I did that, it connected it automatically. But I believe if you go to integrations here, so if you want to go and connect GitLab or something else in here, you just need to go through and follow these specific specific instructions here. So I personally already did set up my GitHub here, so you can see under my integrations here that my personal GitHub is already set up in here. So this part is already good to go. Check. All right, so next thing that we need to do is we also need to set up our credentials for being able to push anything out into AWS. And so the way this works on Scalr is this is called a provider configuration. And so with a provider configuration, what we can do here then is we can create our providers. So you could see here that we could create an Azure, we could create Google. I'm trying to make this a little bit bigger for y'all. And so then we can create one of these providers. So let's say AWS here. I'm going to call this stream AWS demo, not what was demo AWS demo. Okay, and then you have a couple of different authentication types here. I personally don't know how to set up all of these, so I do know how to set up the access key though. And this one's rather straightforward, I think. So what you can do here is coming back into AWS, if you have a user here, now you have to be an appropriate user here. Like, so one thing I should be clear on is there are multiple ways to do things with Scalr. The way in which your organization probably is going to do things a little bit differently than I'm going to do today. So please follow the rules of your organization. And the reason I say that is I'm definitely going to deviate from what my work would do. So I'm just doing what I'm going to do. So I'm going to create a user. I'm going to call this well, I think I did create a Scalr user, but I never actually used it. Let me delete this. Delete. All right, Scalr user. All right. So I'm going to create a new user. I'm going to call it Scalr user. It doesn't have to be a new user. We basically just need to get something where we get the AWS access key and AWS secret key ID. So I am going to set permissions here to where, like, I already have an admin group already set up. Again, this is a little bit of an like a intermediate stream. I'm not going to talk about like how I set all this stuff up, but basically, like, when I add the user to this group, I'm basically going to get administrative access on this particular user that I'm creating here. So yeah, user has been created now. So now if I come into here and I want to get like the AWS secret key and stuff, then I can do that here. I'm going to stop sharing my screen for a second just in case, like, because I don't remember if it shows the sensitive information immediately. Okay, no, it does not. Hold on. All right. So when I didn't mean to do that, sorry. All right, so when I clicked on it, this is what it came up with. So I'm going to just do the command line interface. I understand. Next. All right, and then I'm going to stop sharing my screen again just in case I don't want to accidentally reveal this thing. Okay, so actually I'm going to show this. So just to be clear with you. All right, so this access key here, this is, I would say you should not go sharing this, but it's not as sensitive. Now, what gets sensitive is if you start showing both. And to be clear, I'm just going to delete this right as soon as the stream is immediately over. But basically, what you want to do here is then you want to take the access key ID, go back into the here where we are at putting like our. Remember, we're creating the AWS thing. We're creating giving it a name of the stream AWS demo, and then I'm going to pop in this here. And then I need to provide the access key ID, which I also get from here, which I'm going to have to show. So I'm going to stop again, sharing my screen again just for a minute, just long enough to where I can fill this in. All right, I'm going to fill this in. Okay, and then I'm going to done. All right, so now you can't see that anymore. All right, now let me go ahead and start sharing my screen again. Okay. All right, so I'm sharing my screen again now. Now I'm back in here. So I've already pasted in the access key ID and the secret key. Now we can just go ahead and click create. So now we have, all right, so let's recap. Oh, Kevin. So, all right, so like, all right, so we have created this. Why is it not creating? Did it create? Oh, maybe it did create it, just, yeah, it didn't exit away. Okay, so we've created the provider configuration check. We've connected our source code provider. Now the next thing that we need to do is we need to create what is called an environment. So an environment, the way I like to think about it is it's basically a place where like you want to deploy stuff to. So you may actually have multiple environments per multiple AWS accounts. So like you might have 2 AWS accounts where one is a dev environment and one's a production environment. So what you would want to do is then here in Scalr is create two different environments appropriately here. So I'm going to create an environment, and I'm going to call this just stream demo. So just my stream demo here. All right. I'm definitely going to delete that access key now. Yeah, I mean, I was going to anyway, but now I'm really going to delete that access key. Anyway, so now we've created the environment. So let's go ahead and go into the environment. Now we need to connect our provider configuration here. So we need to go into provider configurations. I know this is a little bit small, so I'm going to try to zoom in as I can. So I apologize if you're struggling to see there. So I'm going to go into manage what I want to do here. So I forgot how to do this part. Like, this is the part that was... Oh, I think you actually have to do it in... Okay, so let me go back to provider configurations here. Then you go into your stream demo, like the provider configuration that I called here. And then you actually have to give it access via here. So I'm going to just... yeah, environments with access to the stream demo. Save changes. All right, so... All right, so now what we have done, just to kind of recap, because we're moving a little bit quickly, we've created our environment, we have connected our AWS provider configuration over there, and we have connected over GitHub. Now, but we've only done these things at a holistic level, but we want to actually get a little bit more specific, and we actually want to have it fire off on one of these different directories over here. So actually, the one thing I want to do here really quick, so like, so in my, over in here, so we got a couple different directories. I actually do want to create a new directory. So I'm going to call this, not a new file, new directory. I'm going to call this, what do I want to call it? Just stream IAM role. And then I'm going to create just a dummy get keep file in here. New file, get keep. All right. So if you don't know what a get keep file is, it's like, so if you push directories up to GitHub or GitLab or anything like that, and you don't have anything inside the directory, it won't push up the directory. So get keep is kind of just like a dummy way to get the directory to show up without actually doing anything. So basically, this get keep file does nothing. But you'll see why I want this here in a second. So, all right, I'm gonna call this adding new directory with .get keep. All right, and push. Okay, did that work? Let's check to see if that worked. Okay, so you can see in here now we do have our directory with just the get keep file in here, which I will delete here in a minute. But you'll see why that I want to do this, and the reason that I want to do this is so now, in order to actually deploy out things per like at like a project level, I would say you would want to create an individual workspace underneath the in the environment. So you can see here I've already got one here that for our OpenSearch vector store that we will be using in a later stream. But we're going to create a new one. So I'm going to create this new one here. I'm just going to call it, or I'm going to assign it to my my stream demo workspace, or my stream demo environment, I'm sorry. And then I'm just going to call this stream IAM role. Doesn't particularly matter. And then, so you can actually, this is where you would set here if you want to trigger things off via like version control system or at like the CLI. Again, other companies and stuff, like most enterprises actually do the CLI. I'm just going to keep it at VCS just to keep my things easy for myself. So I'm going to select my GitHub provider, which again, I've already added here. And then we're going to go to my repository that I'm working out of here. So that is the LM rag guide. And then so we want things to fire off when it's on the main branch, and then specifically I want it in the and so now you're starting to see why I wanted this directory here is I want it in anything that to detect changes specifically from within this directory here, this stream IAM role directory. And so actually there's actually another thing that I forgot to do here. So the way that I like to manage my my configuration variables is I will create a new directory in here, config, and I'm going to create a new file in here, default config.tfvars. All right, I'm going to push this up. I guess I don't need the get keep file anymore if I got this in here. All right. Starting default config tfvars. All right, and right now I'm just pushing directly to the main branch. But so typically speaking, like you would actually in a real like project scenario, you'd probably want to protect your main branch and then have people push off to like a side branch and then merge in, which we're going to do here in a minute. In fact, let me go ahead and change that over right now before I forget. So repos cdlm get. All right, so git branch stream IAM role, git checkout stream IAM role. All right, so now we are working on that branch. All right, so yeah, anytime we wanted to detect if there's any changes here, and so we do want to keep this dry, the VCS driven dry runs going. So if you are familiar with the Terraform plan command, that's basically what this is doing. Is it's just running the Terraform plan command for you. It's kind of nice. So we're just gonna keep that enabled. And then this is the thing that I was just creating here is the var file. And so I'm gonna note that our var file is in the IAM role config. And then you actually do, I don't know why it doesn't detect it. You do have to type it in though, default config.tf vars. And then I got tripped up on this. You do actually have to click this add button or else it doesn't register. And then this is where, like, as of today, like, Scalr is supporting both OpenTofu and Terraform. I don't know if it'll support Terraform going forward, but to just select this is just as simple as clicking that. All right, so we're going to create the workspace here. Okay, so we've created our workspace. So now this workspace is basically ready to go. So anytime we make updates to that thing over there, our actual Terraform code, then it should be good to go. So let's actually go and set up our Terraform code to be able to do this now. All right, so within here, within our directory, so this is the directory that we're working out of. Like, there's basically nothing in here right now. So I'm going to create a couple files. And again, this is where we're not really going to talk too much about how Terraform works. And in fact, like, so I mentioned I would talk about learning resources for you. So Terraform, I bet it's still the number one on here. Oh, no. That is not the one that I took. The one that I took is this one, Zealvora. Zealvora. I know it says that this is like a certification one, which technically there is a certification that you can get. This is the course that I took. This course was excellent, and I took it several years ago, and I think it's still just as relevant as it was then as it is now. And I do see that it looks like that Zeal is keeping this updated, so I definitely recommend this course. Again, there really hardly is any difference between Terraform and OpenTofu. In fact, like, well, you'll see the syntax here, but anyway, I'm not going to talk too much more about like how Terraform works. So, yeah. So anyway, I'm going to go back in here. I'm just going to create a couple files. I'm going to create the backend.tf. I'm going to create the variables. Oops, not varo. Didn't mean to do that. Variables.tf. Let me make everything bigger for y'all. There you go. New file. All right, I'm just going to create im.tf. And is that all I need? Let me check really quick. Oh, my locals. So again, if you know how Terraform works, then you know that you don't have to do what I'm doing. You can technically throw it all in one TF file. I just like to keep them logically separated out like this. So the most complicated part here is setting up our backend, and even this is not complicated. So again, this is where things get a little bit weird. We are still working in OpenTofu, to be completely clear, but to set our backend, we have to type the word Terraform. So that's why, like, you know, working in OpenTofu is actually extremely easy. Like when I first started researching it, I got a little bit nervous, but I'm finding that it's actually, like, there's nothing to it. All right, so backend we're gonna say is remote, because we're going to be using Scalr as the backend. And so we are going to setting the Scalr host name and organization environment, aka the environment name. Okay, so host name equals, so when you sign up, it'll actually tell you what your host name is. It's always going to be something.scalr.io. So .scalr.io. So it's going to be your your company name typically. So for me, so this is the name of my account. Let me see if I could find that somewhere in here. I'm not 100% sure where this would be at. Maybe in here somewhere. Oh, I guess that's the other thing I should mention is, like, both Terraform Cloud and OpenTofu, or I'm sorry, Scalr here have like a free tier to them. So like you can see here that the free tier is like number of runs per month. So you can see here that you get 50 runs per month. So that's just a-okay for me. Like I don't think I'm gonna exceed over 50 runs a month. So, but if you do exceed that, you're gonna have to pay some money. So, yeah, I forget what I was doing. Oh, I was trying to look for that information. Yeah, I mean, you could see even in my URL here, though, that you could see it's dkonly.scalr.io. Then the other thing that I noted here in my code is like, so then we have to put in the organization. Like, this is a little bit of a misnomer. So it says organization name. It's actually the environment name. So our environment is stream demo. Yeah, so that's a little bit of a misnomer. And then we have to set our workspace name. Setting the name of the workspace. Okay. Workspaces equals. Oh wait, no equals. All right, workspaces name equals. All right, what do we call this workspace? Stream IAM role. All right. Now like I mentioned before. Oh, did I accidentally delete my curly brace there? We are the way that Terraform works on the behind the scenes is that you have to download the provider code to support this. So the way that you do that is we're just gonna, downloading the required resource providers. So the way that we set that is required providers, and then it's going to be AWS equals source equals HashiCorp/AWS. And then, so that is it for that Terraform block. Then I am going to set a default region for myself, setting the default AWS region, and that is provider AWS region equals US East 1. Okay. All right, and that's basically it. Like everything else from here is all standard Terraform code. So what I'm going to do here is let's go ahead and create the IAM role really quickly. And so all right, so the way that we do that, so remember we have to create the assume role, what did we call that in the actual, what did we call that up here? Whenever we actually created the user role and not role, but we wanted to create the role to the trusted identity type. Yeah, that's correct. So we need to create that. So we're going to create these as data blocks, and then we're going to attach them to actual AWS resources. So I'm going to call this. I like to use these weird headers. Data blocks. All right, setting the assume role information. All right, so data, AWS IAM policy document, assume role document. So I'm just going to call this assume role document, something basic. All right, so then we need to set our actual statement, actions equals STS, assume role. Principles. Most people don't hand type stuff like this, by the way. Like a lot of this is going to be like copy and paste, or you might have actual Terraform modules to do this. Identifiers equals lambda.amazon.aws.com. All right, and then setting the IAM policy information, data, AWS IAM policy document. So this is the thing that's going to say, okay, I want whatever Lambda function that assumes this thing to have these specific permissions. So in this case, if you recall, the only thing that we wanted to do is give it the S3 list bucket action. Is list bucket or list buckets? I don't know. We will see if it screams at me in a minute. And resources equals star. Okay, so that is the actual data that goes into support, like to build our role. So we're going to build all right, down here, I'm going to call these my resource blocks. So we need to create the actual policy itself. the role, and then we need to create an attachment that attaches the policy to the role. All right, so the way that we do that is I'm going to creating the IAM role. All right, so resource AWS IAM role. IAM role. So in my opinion, the most complex part of today's stream is just understanding the Terraform syntax. And again, we're not going to cover every little Terraform thing out there. That's where that one course that Zielvora I would recommend. Oh, by the way, now that I'm thinking about it, so Zielvora actually posts his own coupon codes. Like he posts them himself. So Zielvora, GitHub, coupons. So like if you want like a cheap way to get these codes, he posts them himself. So that's why I don't feel bad sharing this. Like just go and use one of these codes and you can knock it down to like $12 or something like that. And it's a great course. So I'm glad I remembered that. All right, so we'll talk about what this prefix thing here is in a little bit, but we'll come back to that. So assume role policy equals data dot assume policy document dot JSON. All right, I just did a lot of autocomplete there, but basically what I just did was referencing this data thing that we created up here, and then and like as a JSON reference. Okay, so creating the IAM policy. So we're going to call this resource. By the way, can I tell you how good freaking Nerds Gummies clusters are? Like, I am addicted to these things right now. Oh my gosh, they're so good. All right, back to writing the code. All right, so I'm just going to call this IAM policy. So I guess I will say, if you don't know how to read Terraform code, the way it works is it will tell you what you are creating. So we are creating a resource. And then it will tell you like what sort of resource you are creating. So this is a specific like actual thing. So like if we were to go look at the documentation online, and maybe I'll show the documentation in a minute, like this is the actual name of like the resource that we're creating, and then this is the specific arbitrary name that we give it, that way we can reference it later. So you can see I'm giving them generic names, but there's nothing stopping me from saying this is my name here, like because it doesn't matter. But so you, in a real context, you might want to be a little bit more descriptive than I'm being right now. But yeah, so name. All right, local.prefix role. No, I don't want it, not role, policy. And then policy equal data dot policy document, JSON, and then we are going to attaching the IAM policy to the IAM role. And I actually think there's a way to be a little bit more directive about this, like a way to do that directly. But I'm just gonna do the way I know how to do it. So this is gonna be an AWS IAM role policy attachment. IAM policy attachment. All right, so take a guess. What do we need here? So we need to define the role. So the way that we define the role is AWS IAM role. No, IAM policy, IAM role. IAM role dot name, and then we need to attach the policy ARN. Policy ARN equals AWS IAM policy and IAM policy ARN. All right, so that is that. Now you will notice I did this thing here. So this is a special, like another little Terraform thing. So you can actually create these things called locals, and that is basically a way to, the way that I like to use locals is like so you have your variables, and so I actually am going to create a variable here. I'm going to call this variable equals, or I guess there's no equals, but variable resource prefix. I'm going to say description equals the prefix name of all resources. Okay, so, and again, this is just another Terraform thing. So you don't, so you instantiate the variable here, but if you actually want to use like what the actual, like what is this going to manifest as, then you would do it in here. You would do it in this TFVars file. Oh my gosh, no. I'm pasting the wrong thing. All right, resource prefix equals stream IAM role. Stream IAM role. Okay, and the reason that you do this is because then I can go and create other var files and then swap out the variables. Now, it doesn't matter here for this resource prefix name, but you can imagine that in different environments, you might have different, you know, different security group roles or different VPC conditions or whatever. So that's why you do this, so that way you can kind of parameterize your code and not have to go like mess around with things too much. So then look, I'm going to do in my locals here. Locals prefix equals var dot resource prefix. But this is where you could actually take multiple variables like these and then jam them together in a locals thing to actually like form a whole prefix, which is what I actually do like in a work context. Is I'll take like 3 different variables. It'll be like prod, team name, project name as 3 separate variables, and then in the locals thing here, combine them together to form a prefix, and then use this prefix as a prefix to name everything. So I think, is that all my code? That might be all the code that we need. All right, so now we have gone ahead and created all this code. We'll see if it screams at us here in a minute. So what we're gonna do here is recall, we are not working on the main branch. So because we are not working on the main branch, nothing should fire here. So let's go ahead and add all of our code. Adding all our stream code. All right. We're actually coming up on the end here already. Yeah. No, that's fine. Okay. So let's come back into here, let me close out some of these tabs. So I'm coming back into my workspaces here. And so you can see that nothing has been triggered here. If we go to our runs, we have no runs yet. So let's go ahead and go back into our repository here. So you can see here that, you know, the reason it's not run is because in our settings here, we have set it to only run on the main branch, which is why you probably want to protect that main branch in some capacity. So now that we've set it to run on the main branch, so the way that we can do this is we can then just do a pull request. Now, to be honest, so like in GitLab, it's called merge request, and on GitHub, it's called pull request. I don't know why it's called pull request. I actually kind of like the merge request nomenclature better, but I'm going to go ahead and create it. Now, the cool thing about OpenTofu, Scalr, is that it's going to go ahead and do a dry run even before I actually merge it in. So you can see here that we got this pending plan here, and that is because if we go back into the workspaces and this one IAM role thing here, we should see a pending dry run. So we know that it's a dry run because it says dry right here. And so again, if you are familiar with Terraform in and of itself, a dry run is basically a Terraform plan. And in fact, you'll see the Terraform plan or the OpenTofu plan syntax here in a minute. Okay, so what did I do here wrong? I failed to get the, well, I said something wrong. All right. Provider AWS. All right, locals, backend. All right, I did it right yesterday, so let's see what I did wrong here. So this is from the correct file. I'm just copying it over because it looks like I messed something up, but I don't know what I messed up. Backend, required providers, AWS, provider AWS. Okay, that's all fine. That's all fine. Did I? Okay, well, it's connecting to this properly, but it's saying that with backend. Let's see if Oh, for some reason it's not connecting to my provider configuration here. Okay, so that's problematic. So maybe it's just that I did not. Maybe at a workspace level you'll also have to add the provider this configuration thing here. So let's go ahead and. But I don't think I did anything wrong here, so I'm gonna go ahead and undo all this. All right. So let me go ahead and try to do this run again. Can I do it again? Restart run. So this is just, again, doing the dry run here. And then we'll do the real deal here in a minute. Ugh. It's been a week. I am tired all. Went on a work trip this week to Atlanta, and it was a great time. But, you know, it takes it out of me, man. I am tired. And then I did 4 hours of lawn work and stuff this morning. Okay, this time at work. Okay, so it was just a matter of like I actually had to like connect the other thing. So you can see the plan here is just about done. So if I actually yeah. Sorry, I got distracted. All right, so this has completed now. So you can see here that all checks have passed. Then we can go ahead and merge this in. So if we merge this in now, we should see another run appear, except this will be our real run. All right, so refresh. Did it not merge? Oh, yeah, that's right. I got to click the confirm merge button here. All right, so confirm the merge. Let's go ahead and refresh. So you can now see that it is initializing. So we should actually be able to create this role and then see it inside of our AWS account. I forgot what I called this. So stream IAM role. That's what the prefix is. All right, 3 to plant, 3 to add, 0 to destroy. And then we will do a quick destroy here, but and the only reason I'm going to show it is just to show like a little caveat here. All right, so I forgot that the way I have this set up right now is that you actually do have to do an approval on this, but where is the approval button? Where's the approval button? Oh, pff, darn it. All right, there's the approve. Here we go. So you actually do have to click an approve button the way I have it set up here. Again, there is multiple ways to set this up. Like I'm having it set up based off of like a push to a GitHub, but like a lot of companies opt to have it just, you know, run via the CLI command. Okay, so it says that we created everything. So let's go ahead and actually go into our AWS account here then. Get away from there. Oops. Probably needs a refresh. All right, there it is. Our stream IAM role with the dash role. It was created at 15:32, which is exactly the precise time here, just to prove that this is it. And then you could shoot. So this is the role itself. Now, why is it not showing the permissions associated to the role? That's concerning. Maybe I just need to refresh it. Okay. Just needed to refresh it. There it is. So this is the policy that we created. And recall that we just wanted it to have the S3 permission of just listing stuff. So this is just in the UI form. If we want to see it in JSON form, we just click the JSON button, and there we go. And so now if we want to delete this IAM role, now in the future, like let's say we want to add more stuff to this, we just simply go into the Terraform code and continue to add more stuff to it and push things in. But like let's say I'm good with this, I don't want it anymore, I don't need it anymore, then you need to go back to your actual like workspace here. And then what you want to do is you want to go to settings, administration, and then you want to actually first destroy the infrastructure and then destroy the workspace. And actually it appears here that you can't, that Scalr has it where you can't do them both at the same time, which technically speaking, I think well, technically speaking, you can. Like you could destroy the workspace and then, but like it would just keep all the infrastructure around. So I am going to do just a straight up destroy here. And so this is just going to very quickly destroy our IAM resources. And then I'm going to get rid of that my one user there, since I revealed that access key, and now I'm nervous about that, even though I don't feel like I should be. I don't feel like I should be, but I'm going to anyway. All right, so it should delete here in a minute though. And then we'll call it a day. All right, it's going to force me to Do a approval on this again. I got a nerds cluster while I'm waiting. Any questions before I wrap up today? Because we're coming up on the end. All right. So actually, when I refresh this thing, this thing should be gone now. Yeah. So if I go to roll, yeah, it's gone. We're 35 now. 34. It's gone now. Okay. So I am gonna go back into this user and then the Scalr user thing here. I'm gonna delete that. Delete user. And then I guess for my own sake, I'm gonna go and delete these other things. So I don't need this workspace anymore. So I can delete the workspace. Administration, delete workspace. Stream, IAM, role. Okay, don't need that anymore. And then I'm gonna go to my environment. Manage environment. Where do I delete the environment? Delete the environment because I don't need this anymore. Stream demo. And then provider configurations, the stream. Delete this. Delete. All right. And that's it. So now you know the gist of how to do deploy stuff to AWS with GitHub, Scalr, and Terra. I keep wanting to say Terraform because it is so much like Terraform. I feel like I often forget it is OpenTofu, but it is technically speaking. Okay, that's it for today. Hope you all have a good weekend, and I will see you in the next one. Bye.